And thank you very much for joining this event, particularly the in-person participation in this very late afternoon and evening time. I'm Junior Lee, coordinating lead author of Working Group 1, Chapter 4, and I'm the one of organizer in this event on climate information for near-term preparedness and risk management. And this event is basically a joint effort between IPCC Working Group 1 and Working Group 2 to facilitate the communication between two groups, particularly for the next cycle of IPCC report. And also, I'd like to thank to the Working Group 1 Technical Support Unit to prepare this event, and also Jasmine for preparing this event. Thank you so much. And this event, we'll have the presentation and very short panel discussion. And Dr. Richard Jones, the coordinating lead author of Working Group 1 Atlas chapter, will modulate this event. So I will hand over the microphone to Richard.
Okay, thank you very much. Welcome everybody. Welcome to everybody who's online. So we're going to start with two presentations from the Working Group 1 authors, and then we'll have a little bit of time for Q&A after that, and then we'll go on to presentations to the Working Group 2 authors, another Q&A, and then some information from the World Climate Research Programme from WMO, and then a discussion at the end, which will be chaired by Uni. First of all, without further ado, I would like to invite Uni to come up and give her presentation. Thank you.
Okay, thank you, Richard. So I give a kind of a scene-setting presentation first, and mainly focusing on the near-term climate information for adaptation and risk assessment assessed in the IPCC AR6 Working Group 1. And I'm Junior Lee at Busan National University and Institute for Basic Science Center for Climate Physics, South Korea. And as you know that in the Working Group 1 report, this time we emphasize the regional climate information, and 1/3 of Working Group 1 report were dedicated to regional climate information. And also one of 4 sections in Working Group 1 summary for policy makers was dedicated to the climate information for risk assessment and regional adaptation. And the physical climate information addresses how the climate system responds to the interplay between human influence, natural drivers, and internal variability. But mainly the global climate change is a global phenomenon, but its consequences and also manifestation are different in different regions. So the regional or local information can be used for impact or risk assessment. And I'd like to mention about the methodological advance assessed in AR6 Working Group 1. And in this report, we emphasize the importance of distillation involving scientists and stakeholders all together. And the distillation process can draw upon multiple observational data sets, ensembles of different model types, process understanding, expert judgment, and indigenous knowledge. And also there are important elements for distillation, including attribution studies, the characterization of possible outcome associated with the internal variability, and a comprehensive assessment of observational, model, and foreseen uncertainties and possible contradictions using different analysis methods. We also emphasize that taking the values of the relevant actors into account when co-producing climate information and translating this information into the broader user context improves the usefulness, fitness, and uptake of this information. So, effective regional climate information requires shared development of actionable information that engages all parties involved and the values that guide their engagement. And in the AR6 Working Group 1, you can find many advances, but also you can find that there are many gaps and limitation for providing useful climate information for decision makers. So that part should be further developed. And in the working group 1, we newly defined climatic impact drivers, which better connect and better linking working group 1 and working group 2 assessment. And Amjad will introduce the climatic impact drivers more in his talk next. And then I'd like to touch upon some important scientific advances in working group 1 for near-term climate information development. But my talk is more the global scale improvement, and Amjad will further introduce the improvement in the regional climate information. In the near term, the additional emission from human activity will add additional warming. In addition to that, simultaneous changes in methane, aerosol, and ocean precursor emissions, which also contribute to air pollution, lead to a net global warming, particularly in the near term. And also we assess that natural drivers and internal variability will modulate human-caused changes, especially at regional scales and in the near term, with a little effect on centennial global warming. And here, internal variabilities mainly includes most of variability with different time scales from sub-seasonal to interannual to interdecadal, but mainly important most of variabilities are El Niño Southern oscillation on interannual time scales and Pacific decadal oscillation and Atlantic multi-decadal oscillation on multi-decadal time scales. And those modulate the climate variation on those time scales, and also important for risk management and adaptation, and also short-term decision making. We also advanced in identifying sources of uncertainties in near-term information. And internal variability plays dominant role in the near-term framing. And here we define near-term from 2021 to 2040, so the next 20 years, which will be the crucial time frame for humanity to respond to man-made climate change. And we also show that single model initial condition large ensembles and storyline approaches, which are newly advanced in AR6 compared to the previous cycle, provides a more comprehensive spectrum of possible changes associated with the internal variability. Model uncertainty also play a role in the near term. And now, scenario-based projections for global surface temperature are better constrained based on past warming simulation. And also in the near term, uncertainties in forcings from natural and anthropogenic aerosols play some role, and our understanding on the role of those aerosols have been improved further. And this is one of the important advances in the IPCC AR6 Working Group 1. Now we provide the comprehensive assessment of future changes in global surface temperature, ocean warming, and global mean sea level based on multiple lines of evidence. Particularly for the global surface temperature changes, we combine the scenario-based projections with observational constraints, as well as the updated information on climate sensitivity. With those advances, we substantially reduced uncertainties for the future changes of global surface temperature, and also for the near term, additional information from initialized decadal prediction was used. And using those approaches, we enabled a new estimate of when 1.5 degrees Celsius global warming is reached or crossed. And in the Working Group 1, we use 5 illustrative scenarios, and we show that except the very high emissions scenarios, SSP 5, 8.5, the central estimate of crossing the 1.5 degrees Celsius global warming lies in the early 2030s. In addition, by 2030, global surface temperature in any individual year could exceed 1.5 degrees relative to 1850 to 1900, with a likelihood between 40% and 60% across the scenario considered. However, it is important to note that the individual year global surface temperature anomaly exceeding 1.5 degrees Celsius doesn't mean that global warming will reach the 1.5 degrees Celsius. Nonetheless, this individual year accidents is very important for risk management and short-term adaptation planning. Also, we better constrain the future change of global mean sea level based on multiple lines of evidence. So the future change was combined with climate information and ice sheet and glacier simulations. But since the global mean sea level responds to the greenhouse gas warming much more slowly than global surface temperature, the scenario dependence in the near term is very weak. But he has long-term commitment consequences, so this is important. And also, in addition to the global mean sea level rise, there are extreme occurrence of storms, cyclones, which add the risks of sea level rise in many regions, including some Pacific islands. So those are very important for risk management over those regions. But we have one issue here. Because we don't have strong evidence to constrain the other climate variables beyond global surface temperature or global mean sea level, the projection for the other climate variables for the future change were only based on the CMC's projection and also expert judgment. So we actually need more studies to better constrain for the other climate variables beyond global surface temperature and global mean sea level. Then also we emphasize that the part of the climate system that have shown clear increasing or decreasing trends in recent decades will continue these trends for at least the next 20 years. However, a period as short as 20 years, such as near term, these trends are substantially influenced by natural climate variability, which can either amplify or attenuate the trends expected from the future increase in greenhouse gas concentrations. But nonetheless, the global warming approaches provide fill the gap for the different approaches between the global mean surface temperature and other climatic variables. So this is the example. So this is the example of a global warming level approach for annual mean precipitation and mean soil moisture given different global warming levels. And then you can see some regional changes depending on the global warming futures, different global warming futures. Okay, this is my summary and short discussion. So you can see that there have been advances in methodological and scientific advances in providing near-term climate information assessed in AR6 Working Group 1. And in particular for the near-term, especially global perspective, there has been improvement in projections of near-term evolution of the climate system, and we better identify drivers for near-term climate changes, and also we better identify sources of uncertainties for near-term climate changes, and also there has been improvement in methodology for better climate information based on multiple lines of evidence. However, we also see some gap and limitation to provide qualified regional climate information, which can better support adaptation and risk management, and also even short-term mitigation policies. So I think that is the area we really need to put more effort for the next several years. And there has been recent development in WMO World Climate Research Program. The name is Lighthouse Activities. Then Kirsten will introduce those activities more details. Okay, that's all my presentation.
Okay, thank you very much, Uni. We'll save questions until Amjad has given his presentation, then we'll take questions on the Working Group 1 contribution. So, and thank you very much for keeping exactly to time on that for 10 minutes. Amjad, over to you for the, your presentation. Thank you.
Yeah, thank you so much, Richard. This is the IPCC Interactive Atlas for Working Group 1. So, around 5 years before, the member governments requested to assess the climate at the regional level, so where the people live, so which may help in decision making and risk assessment. so that will lead to the better adaptation. So we, in the leadership of Richard Jones and Jose Manuel and Gemma Tressa Nerisma, who is no more with us. So we dedicated this chapter in the memory of Dr. Gemma Tressa. So
Amjad, could you bring the microphone a bit closer so that
okay,
that's
okay.
better, thanks.
So this is the chapter Atlas in Working Group 1 is embedded in almost entire report, and the frequently asked questions, regional fact sheets, and recently we have also prepared the sectoral fact sheets as well. So and this is overall structure of the Working Group 1 report, and this is the last few chapters are dedicated for the regional climate information. This is how the interactive atlas in the Working Group 1 works. Like, we have divided the whole land region into 46 land regions and 16 ocean regions. And in addition to that, we have few more the climate impact drivers which been assessed in the online tool. So this graph is just to show the how the different regions are affected and the level of confidence in different region with the of the climate impact drivers. So the chapter Atlas has two parts. One is in the part of the report, and the other one is online tool. So and this is the team from entire the globe who've been working for this Atlas, and yeah, where this is the photo shot of that. So as I mentioned, we assess the information on region by region at different scale, at different warming levels, and different seasons, and make it more flexible that the user can choose and assess for what kind of information they need. And so as I mentioned, there will not just the land regions and 12 ocean regions. There are, you can assess the climate over the small islands, monsoon regions, major river basins, and Working Group 2 continental regions as well. So this is the landing page. So you can see the Atlas is in 4 components. One is the simple version, where it can help in teaching and helpful for decision makers, and the other one is the advanced version of this, which is helpful for the practitioners and decision makers and scientists, and there is a regional synthesis part in this, and the 4th one is the documentation of once again. So as the main purpose was how the climate is affecting the people at very regional level. So this is the one of the demonstration that how you can see the information. For example, here the how the fire weather will be affecting in the future. So, and you can see the global regions where the level of confidence. So this is once again whole list of climate impact drivers, so, and include with different regions, and the level of confidence shows which variables is changing in which region. So this is these climate impact drivers and how many of them has increasing trend and how many of them have increasing. So you can see the 96% of CIDs and half region are changing significantly in different regions. Once again, as the regional synthesis report, you can see the this the the level of confidence. For example, here for the once again for the fire weather, that how it will change, and you can see all different kind of variables. 26 variables, you can see how they are changing in different region. And not even this, you can find each region in this synthesis, and you can see all the level of confidence and the arrows signs which shows the increasing or decreasing trend for every region. So this is for the just for the demonstration purpose. So this is the landing page once again, and it is not just this one. So we can assess all different kinds of extreme indices in while you go online, and you can see some derived atmospheric and oceanic and other variables as well. You can see how the different regions are going to change under the different global warming levels, and extract multiple kind of information in the form of tables and graphs, both at the end for different periods and for different baselines as well. So you can select different baselines and observe data, so for each of your region, so that to assess the climate for this is how the as I mentioned before, I mean simple version of the atlas, which is shown how the temperature change under different warming levels, and again for precipitation as well. And once again, you can interface with different observed trends and paleo and the projected changes under medium term, long term, and of course the near term as well. So this is you can see here that on the near term basis how the information you can assess the temperature change for a particular region. This one is for South Asia. So how the temperature at what time is going to change with the 34 models. This is to see the head crew data sets because as I mentioned, there's a whole list of data sets where you can choose different observed data sets for each region, and you can assess different variables, different climate impact drivers, and whole bunch of information for different seasons and months, etc. So here, this is the example. When you choose a region, for example, this one is West and Central Europe. So you can see how the temperature is changing the globe. This is for the scenario for the long term basis, and the same for the near term basis. You can assess at whole globe level, and as well as at the regional level as well. So this is the example, so which illustrate the how you select the period and the level of uncertainty along with that. This is the annual cycle, and this shows how the temperature will be changing for different months and for near term and medium term and long term basis. As I mentioned before, we have a whole list of variables, so you can do this exercise for all kind of variables, both for the atmosphere, ocean, and other variables like surface ozone, etc. This once again for the number of days above 40 degrees centigrade, so you can see. So coming up, this whole exercise has been done on the FAIR principle of and all the information available here, and you can reproduce it using this information, and we have mentioned that how each of the information has been created in the atlas, and anyone can reproduce it for the sake of transparency, and the aligned, the behind code can also be accessed, so that user may know how this information has been produced. And this is not a way, you just need to go online and you can see this few webinars which been arranged by IPCC for different regions, and you can learn more about the interactive atlas and use that information for your own specific needs. Thank you so much, Richard.
Okay, thank you very much. Okay, thank you very much, Anjana and Uni. Okay, so we now have 5 minutes for questions for the Working Group 1 presentation. So can I ask anybody in the audience if they have the audience physically any question?
Yeah, thank you very much.
If you could state your name. If you could state your name and where you're from, please.
Yeah, my name is Zhu from Madagascar. Thank you very much for the presentations. I have a question for the first. Why do we don't have regional information? Maybe in my point of view is also because we do not write papers, we do not write peer-reviewed articles because we do not know how to do it. There's a lot of studies in the national level, but we are not used to write peer-reviewed international publication. So maybe there is also a question of funding. There is a lot of process to get to it. So my question is it if we have, like, we know on the country that universities are writing reports, they are not designed as peer-reviewed or internationally published, but it is internal reports or technical reports. How is a way for these reports to be taken account in IPCC assessment report, if there is any chance? And the second presentation, we really are thankful to Working Group 1 that Madagascar is a whole region that is really helpful for us, because only from this atlas we have Madagascar like national level, if I can say that, but we need to go a sub-national, and I'm thankful that it is reproducible. I do not know if it is how difficult is it to reproduce it. Is it possible that we do it in the next 7 years so that we can have information like this, but in sub-national? So do you think it is how difficult it is to reproduce it, or is it feasible? Thank you.
Okay, thank you. Thank you very much. So if I can direct the first question to Uni about the use of grey literature, and then maybe Amjad can take the second question.
I think the first question is very important, and inclusive is the most important aspect we try to consider more, and also we see that there are some gaps and differences in the regional climate information assessed in the peer-reviewed literature. So in the AR6 Working Group 1, we try to include some gray papers if possible, if the evidence is robust in the gray report. But I found that actually there are not many gray papers actually used in the Working Group 1 report. So I think this is some part we really need to consider further. And also I think we need more international collaboration to solve this problem. And I know that under the WMO World Climate Research Program, they have new lighthouse activities on, I think, training and workshops, which facilitate this further science development in the least developed countries. So, yeah, this is a kind of a limitation in the current report, but that should be further improved in the next cycle of IPCC report. Thank you.
Thank you so much for the question. I think the idea to create the information at the subnational also been discussed in IPCC in multiple times during the creation of this tool. But you know, this is something not the mandate of IPCC, and this is your national climate service providers. So until now we have just been reached at the regional level, and if you want to reproduce the information from this particular tool, it will be at that particular region where you want to. But there is a flexibility of you can draw some information at point level, so you can create to reproduce it, the online data and the scripts behind it, and hold the steps which has been carried out to create that particular graph is already available in the online tool. But to reproduce it at the different region, you may need to do some extra work. I mean, you can access the data, but you need to do something extra for that. Thank you so much.
Okay, do we have any other questions in the room? Okay, in that case, I think we'll now move to the Working Group 2 presentation. So can we have another round of applause for Yunyi and Amjad? Thank you. And if I could now invite and Martin to come and join us on the stage. Thank you. So now we'll have two presentations for the Working Group 2 from the Working Group 2 authors on this subject, and I'd like to invite Zelina first to give her presentation on advances in adaptation and risk assessment in the AR6 Working Group 2 report. Zelina, thank you.
Thank you very much, Richard. Thank you for everyone for staying. I'm Zelina Ibrahim. I'm a coordinating lead author for Chapter 16, Working Group 2, which looked at key risks across sectors and regions. And today I hope to give you a very short summary of what this chapter was and what were the advances we did in the assessment for adaptation and risk. So we looked at impacts and adaptation, key risks across sectors and regions, from which we managed to identify representative key risks and updated the reasons for concern across the scales. And finally, I'll just give you some of my reflections and thoughts as a result of the development. So, impacts and adaptation. In order to assess the impacts, we also went through a process of attribution of the impacts to climate hazards. And we saw that these impacts are being observed in many systems worldwide. For ecosystems, these changes are affecting the ecosystem structure, species range, and timing of events. In human systems, we've managed to categorize for water and food, health and well-being, cities, settlements, and infrastructure as being areas where we find a lot of evidence on the literature of the different impacts. Some are increasing the adverse impacts, but there are some positive impacts also being seen, but very few. But these impacts are all widespread, and they have related losses and damages with them. But by region, we see there are different types of hazards and adaptation-related responses. And this assessment has been based on a review of literature from a new data inventory, which is the Global Adaptation Mapping Initiative, or GAMI, G-A-M-I. And this has looked at several tens of thousands of papers on adaptation, looked across regions and also different topics. And we'll take a look at Africa, for example, where we see that the main hazards, climatic hazards, are drought, precipitation, flood, heat, and sea level rise, with the very dark colors showing a high evidence of hazard and adaptation-related responses. And most of these responses, you can see the high ones are for food, health, and poverty. We also did an assessment of key risks across sectors and regions, and we compiled all the key risks identified by the different chapters as well as the cross-chapter papers. Here we see a figure of something which would be, we might consider as a slow onset impact for coastal erosion. And the houses up there would find it very quite hard in order to do any adaptation. And you can contrast it with some extreme events like a storm hitting a coastal area, but where, for example, the structure is built to withstand some of these storm events. So actually you're having these key risks being maybe slow, insidious type of process, or something which are very extreme events. Now, in the assessment of risk, we found more than 120 key risks across the different chapters. And similarly, as Junyi mentioned, we looked at multiple lines of evidence. And from this, we managed to identify 8 representative key risks. So this is an update from the AR5 assessment of key risks. And of course, we updated the reasons for concern. Let's just take a look at the representative key risks, or the RKRs. So what we find when we do an assessment of the severity conditions, and this is something which is quite worrying, we might anticipate that it's only with high warning we would get severe conditions. However, we see that for water security, and for example, low-lying coastal systems, just low to medium warming combined with high exposure and vulnerability, or with low adaptation, you would get a very severe risk condition. So this is something where near-term information on climate would be very useful for us to indicate which specific areas would be most exposed and would benefit most from actions taken. In addition, when we looked also at the reasons for concern and the update, we actually find that we're achieving higher risk at lower temperatures compared to AR5. So let's just look at what the near term would bring. Here we see for the near-term global reasons for concern, which are threats to unique and threatened systems. RFC1, RFC2 is extreme weather events, and RFC3 is distribution of impacts across the globe. Global aggregate impacts RFC4, which includes the economic impacts, as well as RFC5, large-scale singular events. And we're seeing that we have very high to moderate risk levels at much lower temperatures. And in fact, we're in that range for RFC1 of already moderate and moving towards a very high risk impact at temperatures of just below 2 degrees centigrade. So that's something we hope can provide input to decision makers into how the problem is very urgent and that action needs to be taken. But of course, climate change is not uniform, as we see from this map from Working Group 1. And that's the reason why we can benefit a lot from future information about what might happen, because even the biodiversity loss varies for different areas, depending on what the temperature would be. And in addition, vulnerability of societies varies geographically and within communities. What you're seeing here is actually a summary based on a country level, but actually within a specific country itself, among different groups of population, you'll have different segments of population at different and varying levels of vulnerability. So it's very important in that sense to try and do an assessment at the national, and we had a question at the national level, in order to better understand what types of actions are needed. In order to try and connect across from the Working Group 1 work, we try to link between the CID, or in Working Group 2 parlance, hazards, climatic hazards, looking at the regions. And you had seen just now, Mr. Amjad presented what was the CID impact on different regions. And then we look at the representative key risks and also looking at the SDGs. The SDGs as a nationally, reported status of the country. It also produces information about potential challenges or issues being faced in achieving sustainability, and it can be taken as a proxy of the systemic types of issues being faced in order to achieve sustainability. Let's go further down, because this diagram is quite massive. If we look now to see the CID, you can see at the top corner, and what you're seeing there is actually a summary. In Working Group 2, we summarize by regions. We're not as fortunate as Working Group 1 to have many sub-regions. We hope that we could be able to achieve that, but of course we're limited by the literature that we have. So this is a summary, an agglomeration of all the data from Working Group 1. And so strong colors indicate very high impact, either of increase or decrease. And this will link to the RKR. So Working Group 1 did an analysis of what each CID or hazard, what is the potential impact on the 8 representative key risks. These 8 representative key risks can then be linked to the SDGs based on the literature. So we did a text analysis, and we can then look at each region to see what is the status of the SDG, indicating partially the challenges they might face in responding to these different types of representative key risks caused by the hazards. So we hope that this can be useful for national level, because at the national level they would have to look at their own SDG status. This is just an agglomeration of the whole region. So based on all the assessment that I've been through, these are just some of my personal thoughts, so it's like off script, it's not really IPCC recommendations or anything. One of the big, I think, important outputs from the AR6 report is the issue of complex risk, compound and cascading events. This has been treated also in Working Group 1. The other thing is in terms of the needs for different sectors and regional and national needs. And of course, the issue of extremes and the many different swans that we might have in terms of what probable and improbable events. So we see simultaneous extreme events which compound risk. A very key example is the 2011 Thai floods, which resulted in $40 billion economic damage to Thailand. So it's not minuscule, these types of compound risk. But these complex compound and cascading risks, the issue now is that although we have examples and case studies, we still don't really know what are the causal pathways, and this is possibly a research gap, a research opportunity, and possibly even in later Martin will talk about how we can use this in responding, early warning systems and responding to disasters. Maybe trying to evaluate what are the potential cascades, simultaneous events occurring. You see some of these figures inside the report, but we need more literature and more research on that. The other issue is translating the science to sector and regional and national needs, because in order to do the near term, we're looking at decadal type of events, and that's good for planning. But maybe for agriculture, you need to have some forecasting the next couple of years, 1 or 2 years, seasonal type of level. So there's this gap between the certainty with which we can predict the forecasting, the data availability that we have. And in many countries, we don't really have enough data in order to be able to give a very good forecast, or systems are quite complicated, especially in tropical areas. You have very patchy type of systems. The other thing is that Working Group 1 has very clearly stated that extremes are likely to become more intense and more frequent. And this is a very nice diagram I really like from the SPM of Working Group 1, 10-year event, 50-year event of hot temperatures extremes. But the biggest issue for us is now to see these extremes are out of the range of the data that we have been observing. So, what is our period of observed data? Is it good enough to tell about what extreme values we like to have? Are we selecting the right impact indicators? And actually the SDGs are meant for sustainability. They're not looking at climatic impact, so maybe we need different indicators. The other thing is that risk differs depending on where you're from. Some people are risk adverse and some people are able to cope. It's an indication of our resilience. And then what is the certainty of any particular event, or the improbability of some event happening? And so extremes would be just where we need to think about all the possible things which might happen. And what is the internal variability, influence on what we might see in our local situation. And the variability is not only for the climate, but also for the society in which we live in. So with that, thank you very much, and Martin will follow on from this. Thank you.
Thank you, Selina. So here we will take a pause from all these beautiful slides that our colleagues have presented, and that I've also worked very hard on and that are very dear to me. But I thought I'd take these 10 minutes to tell you a bit about the reality of people dealing with this information in practice, but also with the impacts of what we're seeing here in practice. So I wear two hats here. I'm a professor in climate and disaster resilience at the University of Twente, and in that sense also a coordinating lead author together with Selina for the chapter in Working Group 2 that put this all together. Richard and I used to work together in the previous cycle on regional climate information. So I know this world. But my other hat is that I'm director of the Red Cross Red Crescent Climate Center, and I'm here as part of the IFRC delegation, International Federation of Red Cross and Red Crescent Societies. And this side event, as you know, is called Near-Term Climate Information for Preparedness and Risk Management. Well, those folks are doing risk management every single day. And they are confronted with real impacts of what we're seeing here every single day. And they're asking themselves the question, so is that climate change? And what do I need to prepare for now? That system, the IFRC, has made climate its top priority, one of its top 5 priorities for the coming 10 years. We're getting questions from those folks all around the world every day. But then if I would give them all this amazing science that you've just seen, there's very little they can do with it. So there's still a huge gap in what we are producing and what insights that provides to people that know how to interpret it, and what the people that are actually confronted with these risks in practice need in practice. And we are starting to bridge some of these gaps. So one example is we just presented results from an attribution study on both the drought in parts of the Sahel, but also the flooding recently in Nigeria, Niger, Chad. And that is one very practical question that folks are then asking me in my role as in this reference center. So was this climate change? And should I be preparing for more of that? And that is a very practical near-term preparedness question, right? So in the case of the Nigeria analysis, and so one thing is, and this is where the science has really been advancing. I mean, you've been pointing to what we know about impacts of events today, which is a really good element of how people are processing how things are changing. So for the Nigeria floods, for instance, we found, first of all, that for the whole seasonal rainfall, climate change, the best estimate has made that the intensity of this event 80 times more likely. So an event at this intensity now occurs about once every 10 years, whereas without climate change, it would have been very rare. So it's not something people are prepared for. It's not something, I mean, there is very high vulnerability to start with, but also it is something that does come as a big surprise. Whereas actually what this analysis shows them immediately is this is now a 1 in 10 year event, so you'd better get ready for more of that. So if we're able to provide that information in that context, starting with impacts we're already seeing today, contextualizing it in terms of these things, like, okay, so with what sort of frequency will these things come back? And then very importantly, even to be able to do the analysis, these attribution studies don't start with an abstract raster of where the climate information will be. We actually trigger these studies by looking at, okay, so a couple of hundred people died. So that's our reason. That's why the thing comes up on our radar. And then we ask ourselves the question, so where did these people die and why did that flood occur in this region? So we look at where did the rain come from, over what period of time. And then we do the climate science analysis exactly for that, in this case, a particular catchment area over a particular period of time. So you already need information on vulnerability exposure even to ask the question about what hazard you want to analyze. And then afterwards you come back and you ask the question, okay, so this is now 80 times more likely, but also why, even if it was a 1 in 100 year event before, why did it have such an impact? Why did so many people die? And of course you then come to all kinds of other factors that explain why the risk is so high. Poverty, water management, urbanization, in this case also a dam that was releasing water upstream and that was resulting in damages downstream, partly because a second dam that had originally been planned had not yet been constructed. So all of these patterns in how societies are shaped that you also need to analyze, and where you often also get big trends. I mean, what Selina was showing in the case of the Working Group 2 analysis of what actually drives the climate risk in the near term, it's often the vulnerability factors that are a bigger driver in determining what type of risk we will face 10 years from now on than purely the trend in the climate hazards. Urbanization being one big one. Now, if you are urbanizing in Nigeria at the moment, on the one hand, how we urbanize is going to shape that risk. But those folks shaping those cities right now better well think about the climate information that this study now brings to them, but also indeed they could find in the IPCC Atlas. So my plea from all of this, and this study is just one example, we're doing more and more of those, and I think that is one way the interfaces are getting stronger between these different communities. But let's do more of that science, also working together with those folks, asking those questions in the real world. I know, Richard, you've been doing a lot of that also in practice. And then let's build interfaces. The attribution studies we're now doing are using peer-reviewed methods, but they are producing the information in a couple of days or a couple of weeks when people are actually asking that question. So can we organize more of our science in ways that actually provides it at the right time, in the right context, to the right people, in language that they also understand? We did a briefing here for the journalists that are covering the COP, rather than only covering the climate science. So I'd just like to throw some of those elements out there in terms of building the bridges from the abstract information to the needs on the ground. And with that, point to the huge potential of what we've got at our disposal. Because for instance, this attribution study that we discussed this afternoon would not have been possible 10 years ago. That field of science hardly existed, and we have that whole IPCC Working Group 1 community to thank for that. I think you pointed to some of the questions also going from the interpretation of the now to the sort of 10, 15, 20 year near term. And one of the questions, for instance, if you're thinking about lock-in effects and long-term infrastructure, indeed if you're building those cities in these places, is what sort of bands of uncertainty should we be talking about? One of the concerns I have currently is that we are answering the questions in Nigeria in terms of a return period that is already really, really high right now. But because of the communication challenges, we're actually not communicating the uncertainty ranges too much. And I feel that one of the biggest challenges actually we should honestly be communicating much more is the fact that those folks are dealing with higher uncertainties. So the previous example, and then I'll shut up and hand over to the next session, but the previous analysis was one in Pakistan. Again, huge floods, huge questions right away to us. Is that climate change? And so the first, we did again, so what exactly is the climate signal that you're interested in, right? So we separated it into two pieces. One was the whole of Pakistan, in a longer period, the whole monsoon rainy season, but then also a peak, a burst in rain over about 5 days, particularly in these two provinces in the south that were hardest hit. In both cases, we found quite a strong trend in the observations, but we know there's many other climate drivers in that region, including local air pollution, for instance, that we don't fully understand, we know are not perfectly in the models. So we can't immediately say if the observations show a trend that it's therefore anthropogenic climate change. And in fact, when we looked at the models that could simulate this region, we found only we actually found a very uncertain signal for what was happening to monsoon rainfall over that whole region. We found a stronger signal, but still not enabling us to quantify it precisely for the 5-day burst. So we are very, very confident the 5-day burst is getting more likely with climate change. So we could say, yes, this flooding had a climate fingerprint. But then if you look at the whole seasonal flooding, the main signal that they should be worrying about is uncertainty, rising uncertainty, and it could go in both directions. So then I was discussing these results with the World Bank. And they were asking, so what should be the advice for the reconstruction of the infrastructure? And one of the concerns they had was actually that the natural inclination will be, okay, so there is a trend, a climate-induced trend in the extreme rainfall in this region. Let's take a big safety margin and let's build our infrastructure for a 1 in 200 year event or a 1 in 100 year event rather than maybe than the 1 in 50 that we were prepared for. Well, that would cost a tremendous amount of money. And maybe in Pakistan it would be better to spend that money on a good social protection program or on quick relief after shocks, so people are able to pick their lives back up. And ensure that you've got good 1 in 25 year protection that people can really count on, good operation and maintenance of those systems, and then good arrangements so that you're better able to deal with higher shocks, so that you don't overinvest in infrastructural protection, but you have better arrangements for actually risk management, accepting in some cases this wider range of uncertainty and some of these more uncertain outcomes. So again, an interesting discussion that shows how the information, not just on the trends we're seeing, much more useful if we can contextualize it, but also on the bands of uncertainty that we're getting out of these models, is now real questions faced by decision makers, from humanitarians responding to disasters to infrastructure designers in the World Bank reconstructing after disasters already today. So I hope those examples give you a bit of a flavor for how the science that we've been presenting meets practice, and happy to answer questions or follow up in the discussion afterwards. Thank you, Richard.
Okay, so yeah, thank you very much, Martin and Selina, for those excellent presentations. So I'm sure there are questions in the audience. Can I ask a question? Lau, please.
Thank you so much for your very inspiring talk. Actually, my question is for Sir Martin. So I'm Lau from the Philippines, and recently we have been experiencing super typhoons that are rapidly intensified, followed by immediate landfall. But then it's very difficult for us to do an attribution study for this because of the lack of data. And quite honestly, there's no local expertise for doing attribution studies at all. So aside from what you said, that this makes it hard for us to plan for the future, at the same time, it makes us worry that this lack of capacity to do attribution science will disqualify us or will prove as an obstacle for us to access loss and damage financing, which we really need. So I was just wondering how we can make attribution science more accessible for the Global South, and so that it doesn't end up as like a technical bureaucracy, much like the climate rationale for adaptation has become like that. So, thank you.
Thank you. Excellent question, and I would fully agree with your concern there. So I don't think we should construct a loss and damage financing mechanism that relies on the perfect answer from science on exactly how much of the impact is due to climate change, right? That's already quite a challenge on the hazard side. It's certainly an even bigger challenge on the impact side. So that math, I think, as scientists, we should offer pieces of the puzzle that enable the discussion but we should encourage negotiators to find very practical solutions that enable money to flow to where it's needed without creating hurdles that will be impossible to meet in the context where it's going to be needed. Because what you will find is that the places that need the support most will have the poorest data. So we're going to be able to provide loss and damage finance for heat waves in Europe, although even their attribution is harder than people think, but not for, say, floods in Somalia or droughts in Somalia, which we've both had in the past couple of years. Anyhow, to the other point on the capacity building. So one thing with our World Weather Attribution Consortium is actually that we initially also focused on the disasters that got the most media attention, where we also got many of the questions to give those answers quickly. And we wanted to inform the policy cycles also discussing climate change in places like this one, right? But also where the data was available to do these studies relatively solidly and relatively quickly with the tools we had, the models that we knew were performing well for those regions. We have very deliberately shifted that approach. So we are now systematically triggering for disasters that meet thresholds in terms of impacts, and not just because of attention or where the science is easy. We don't answer all those questions because we're not able to pick them all up. And we know some hazards we simply are not able to do, or some places we simply do not have the data. And in those cases where we then think it is potentially possible, we do work with local scientists. And that is partly a way of building those connections, building that capacity all around the world. And I'd say, tropical cyclones or typhoons have been a difficult one all along, right? But we have seen a couple of places where we have been able to do them, including Harvey, for instance, in the United States. We've looked at cyclones in Vietnam. Actually did not find a very strong climate signal, so that's also a good warning that don't take everything as climate change always. Maybe we should follow up bilaterally and talk about the Philippines more. But I do think just getting on with it, trying, and also learning while you do it is a very good way, and we should be investing in those networks.
Question here, thank you. And then one behind. Okay.
Thank you for the presentation. My name is Alvaro Rojas. I work at UNUHS in the risk analytics team. Lately, there's been a lot of discussion of the likelihood of the scenario RCP 8.5, and it's like a back and forward whether or not we should include it in our risk management and our risk management plans. So I would just like to pick your brains on, do you think whether or not we should be using it? Should we go more to more moderate scenarios? I think both of you provided some input on that. Thank you.
June should take that. It's RCPA 8.5.
Yeah, this is a very difficult question because in the working group 1, we don't assess feasibility of individual scenarios. But anyway, this is something very important. Then, considering some uncertainties in the climate system and considering some climate feedbacks, still we cannot rule out some low likelihood event, like a very high warming occurrence, something like that. So I still believe we still need to consider the high emissions scenario or even high warming scenarios for the risk assessment. But I believe this is a very big discussion issue we still need to consider more. And I'm wondering, Martin, or you have any suggestion on that?
Well, I think as we don't have any Working Group 3 authors in the audience, I think we just have to leave it at that, I'm afraid. So can we just take one quick final question here, and then we'll move on.
Oh, sorry for coming back. I'm still Zu. I'm from Madagascar again. Really quick, but presentation in Working Group 2. Madagascar is not in Africa region in Working Group 2, but in the small islands. So we were quite lost. Because we are not really small island, but big island, and there are some evaluation in Africa region we would like to see for us, but it is not available because we are not there. The question is, maybe it is because of the literature we do not have that you choose the region, or if it is not that, maybe on the next assessment cycle we would like to be studied in both, because we are still in Africa, but we are still island if possible. Last There was a question of world climate distribution. This is drought in Madagascar is really climate change or not? Maybe we, and there were many tentatives to answer the question. But some questions are wrong questions. If we have asked the wrong question, we have probably the wrong answers. For example, the precipitation they studied, if you look at the yearly mean, that was not indicated. If you look at seasonal rainfall, maybe we'll have tendencies. Because like we have maximum and minimum that is zero, but we just look on the maximum, maybe it's like that. So there is possible studies, for example, the tropical cyclone season in Madagascar this year is the number one. Like it happened only in 1994. And the question may rise, do we expect intensive tropical cyclone like this one? But I will follow up after the meeting. Thank you.
Sure. Yeah. Yes. So I think there are two ways. In the analysis that I did, I think Madagascar falls into Africa for the SDGs, and also I think inside the Working Group 1, Madagascar falls within the region of Africa, because I think many of the small islands come out into the Caribbean and across the Pacific, as well as in the Indian Ocean. But you can go down and look into the detailed data, for example, from the atlas in order to find your location. And actually all of the all of the data that is presented in the Working Group 2, for example, Chapter 16, the source data is actually available in supplementary material, so you can actually pull out of that information and do the analysis for your own, level. To do that. And if you have any questions, sure, you can contact us for any additional information. Yeah.
Okay, thank you very much. We're running a little bit over time now, so if we can just move straight on. So can we give our Working Group towards another round of applause when we move to the next presentations? Thank you. I'd now like to invite Kirsten Findell to join us. I think she's, hopefully she's online.
Yes, I am. Can you hear me?
Okay, that's great. Thanks, Kirsten. Yeah, we can hear you very well. So if you could go ahead with your presentation on the WCRP near-term climate activities, explaining and predicting Earth system change. Okay.
Excellent. That sounds perfect. I think Junie is going to drive the slide deck for me. Is that right, Junie?
That's correct. She's trying to advance the slides at the moment. Okay.
Oh,
there you go.
There we are. Perfect. Okay, so I am Kirsten Findell. I work at the Geophysical Fluid Dynamics Laboratory in Princeton, New Jersey. But I'm here today as co-chair of the WCRP Lighthouse activity on explaining and predicting Earth system change. These lighthouse activities, indeed, there are 5 of them. Junie mentioned their existence. They're relatively new, just a year or 2 in the making. So what I'm going to share with you today is something about our plans for how we are moving forward to improve our ability to say things about near-term climate and how it is changing. Next slide, please. So as many of the talks today, and as everybody here certainly knows, the signal of anthropogenic climate change is indeed emerging from the background of natural variability. We've been able to say things about mean global temperature for many, many years. But now we're getting to the point where we can say things on shorter time scales and on smaller spatial scales and in a greater range of variables as well. Next slide, please. And we also know that changes in atmospheric and oceanic circulation patterns have enormous impacts on weather and climate all over the world. What I'm showing here in the top plot is a map of sea surface temperature anomalies associated with a strong ENSO event, which is a warming of the waters along the equatorial Pacific Ocean, particularly in the central and eastern equatorial Pacific. That sea surface temperature anomaly pattern has implications for the atmospheric circulation patterns, which has implications then for rainfall all over the world. Some places showing a wetter than normal rainfall season, some places showing drier. So these are enormously important, these anomalies that we see in sea surface temperature patterns. Next slide, please. But what I want to emphasize here is that it's not just the tropical Pacific that matters. The upper left plot is a plot of the Pacific Decadal Oscillation that shows that the entire Pacific Ocean basin has oscillations in it that are on timescales of a number of years, a few years out to a decade or so. And that has implications for things like atmospheric rivers, the likelihood of atmospheric rivers reaching the west coast of North America, where those atmospheric rivers might make landfall. So these patterns play a key role in shaping extreme events and hazards. It's also true that the Atlantic Ocean is incredibly important as well. The bottom left plot is a sea surface temperature anomaly pattern associated with the Atlantic Decadal Oscillation. And the time series in the middle shows that indeed it can move from a positive phase, as in the picture on the left. It can stay there for a few years and then change to a negative phase where you'll see the reverse pattern. And those different phases are going to have different associated atmospheric circulation anomalies, which will have enormous implications for the weather over Europe. So understanding and teasing out all of these interactions of these different modes of variability in the natural system, coupled with changes that are anthropogenically forced, are enormously important, particularly for things like attribution of extreme events and hazards, as has been discussed. And yet, our capabilities for quantitative explanation and prediction of changes like these on multi-annual to decadal timescales are actually quite limited. So that's the focus of this lighthouse activity. Next slide, please. So our overarching objective is bold and a big one. We are trying to develop an integrated capability for quantitative observation, explanation, and early warning and prediction of Earth system change on global and regional scales and annual to decadal timescales. So that is a big ask. That's a lot to undertake, but we really, I think some of the previous talks have really demonstrated that having this enhanced capability and this improved knowledge base is really essential to inform our ability to adapt to our changing climate and improve our resilience to all the changes that are going on. Next slide, please. So this is such a big undertaking, though, that we've broken it up into 3 themes with associated working groups. The first one is structured around monitoring and modeling Earth system change. So we recognize that our 2 main sources of information, our 2 main toolkits, really, for addressing questions about the climate system are both the global observational system, the network of observations of many different, atmosphere, ocean, land, all over the world. And also, the other main toolkit is climate models, right? Climate models give us the ability to actually do like laboratory experiments, right? We only have one Earth, so we can't do experiments on the Earth itself, other than the one we are doing. But within climate models, we can turn things on and off. And that allows us to ask some attribution questions and determine causal factors and causal relationships between all these different modes of variability. So here in this theme, we seek tighter integration of models and observations to both monitor and understand Earth system change. We can address a bunch of really important questions that have been prevalent in the climate modeling communities for years, like how do we deal with persistent biases in model simulations? We know that the models do an enormous number of things incredibly well, but of course we still want to improve the things that are not perfect. We also want to be able to address how do we make sure that all the data that are being observed across the globe are being utilized to their maximum potential. And then we also want to address questions about, well, as we think about enhancing our observational network, where and with what variables would we get the best improvement, the best improvements in predictive and explanatory skill? So these are just some of the questions that we'll be able to address in this working group. Next slide, please. The second working group is sort of the central working group of this activity. It's on integrated attribution, prediction, and projection. And I think it's incredibly relevant to some of the talks that have already happened here. Thinking about all the sources of annual to decadal variability, some of which are anthropogenic, like greenhouse gas emissions and aerosol emissions, land use change, and then some that are just natural, in the natural internal variability in the climate system, like I talked about it in the beginning of my talk, but also things like volcanoes and changes in solar irradiance. So we seek to identify and attribute the primary drivers of Earth system changes on these annual to decadal timescales, and these, they might be different in different regions, different ocean basins, and different adjacent land areas. So one of the key tools that we want to use to try to get at these different attribution questions are large ensembles of single forcing experiments. So what I mean by single forcing experiments, many of you certainly already know about this, but it's essentially running our climate models with just one of these sources of variability turned on at a time. And we run those simulations many, many, many times, so we can essentially develop statistics about the association and the increased or decreased likelihood of certain events happening under the certain different sources, different forcing scenarios or different emission scenarios. So the goal here is to integrate attribution and prediction capabilities in order to provide seamless information for decision making that hopefully is relevant to some of the issues and then some of the timescales that we've been talking about here in this session. Next slide, please. So our final theme and final working group of this activity is related to the assessment of current and future hazards. So here we seek to understand how internal variability and external forcings influence the characteristics and occurrence of meteorological hazards on annual to decadal timescales and in different regions of the world. We will be focusing on subsets of hazards like tropical cyclones, as was just mentioned, heat waves, droughts. These are all really important hazards to study, and they sort of require slightly different approaches. So we'll be focusing on them as sort of classes of hazards, and hopefully developing things like causal explanations. Of up in the upper left, of just a schematic showing, well, if we know what the state ENSO is in, the El Nino or Southern Oscillation, if we know the state that the Indian Ocean dipole is in, does that improve our ability to make predictions about spring rainfall in Australia, for example? And does it improve our predictions and early warning, our ability to make predictions and early warnings, for example, about the likelihood of landfalling tropical cyclones in one ocean basin or another? So our goal here is to use observations, models, and process understanding to deliver robust assessments of current and future hazards for specific regions of the world and for specific hazard classes. Next slide, please. So this is a schematic of the whole activity, of what we're planning with this lighthouse activity, and how these different themes interact and feed into each other and can enhance the benefits of each other. The sum is greater than the whole of the parts, right? So this was a schematic published in a recent paper in the Bulletin of the American Meteorological Society, and it just integrates this whole attempts of the lighthouse activity. Next slide, please. So what we hope will start to develop in the near term, 2024 and onward, that we hope we will be able to start adding attribution statements to these World Meteorological Organization State of the Climate reports and global annual to decadal climate update reports that talk about changing risks of hazards and what the state of the climate is expected to be in the coming years out to a coming decade. Having attribution statements in there would be really helpful. We also hope, as I discussed in regard to Working Group 1, we hope to be able to work with people in the Global Climate Observing System, GCOS, to discuss observational requirements that are well tailored to this explaining and predicting Earth system change effort. Next slide, please. And we hope to have a few tangible benefits to society coming out of this. Quantitative process-based explanation of ongoing and emerging changes in the climate system, improved understanding and quantification of changes in classes of meteorological hazards on annual to decadal timescales, and improved capabilities related to predictions and early warnings. So our goal, our hope is that these efforts will help us integrate attribution and prediction capabilities to provide seamless information for decision-making for near-term climate needs. And I think you can go to the next slide, and that is the end.
Okay, thank you very much, Kirsten. So I'm hoping you can stay online until after Wilfred's presentation, and then we take questions on both the presentations, if that's okay.
Sure, sure, absolutely.
Brilliant, thanks. Okay, so now it's my great pleasure to invite an old friend, Wilfred Mufuma Okia, who is Head of Regional Climate Prediction Services in the World Meteorological Organization, to talk about near-term climate information for adaptation and risk assessment, advances in climate prediction services for near-term preparedness. Wilfred, take it away.
Thank you very much, Richard. Can you hear me okay?
We can hear you very well, thank you.
Yes, thank you very much. So first of all, I would like to thank the organizer for this important platform. And what I would like to do is to try in a few minutes to walk you through some of the perspectives, let's say from the World Meteorological Organization, focusing on the routine delivery of climate prediction service for near-term preparedness. Can you move to the next one, please? I think to kickstart, I will echo something I heard from the previous speakers, which is the idea that not only long-term change of the climate system can cause havoc, but also the multi-year fluctuation of the climate system. And a good example is the rare but the recent triple dip La Nina event, which started in 2020 and which is still continuing. And this event has caused, as you may have heard, prolonged flood in some part of the world, drought in other parts. But this event also highlights key dimension when we think about managing climate risk and opportunity. So one of the dimensions or one of the needs is to be able to provide a scientifically credible and easily accessible climate information to support the decision-making processes. That's kind of obvious, but also you heard from the previous speaker, have the ability to generate climate information of high quality across time scale. So one time scale is not enough. But then the point which is very important to me is one related to the routine delivery. Basically, for the routine delivery, we need to have standard and well-established end-to-end institutional system. This is the angle I'm going to take in driving you through the presentation. And of course, the ultimate goal is to be able to translate the research into operational services. That's something, I mean, given. Can you move to the next one, please? Now, when it comes to the World Meteorological Organization, basically who we are, for those of you not aware of us, we are the UN voice when it comes to the international cooperation on the issue of weather, climate, and water, with a number of members. We have ambition. One of the ambition is to better serve the societal need, and the way we do this is through the delivery of authoritative, easily accessible, fit-for-purpose climate information and services. So services is a key word. We have also the improvement of the observing system and the predictive capacity, and also to advance the research, plus many others. Now, in doing so, we base our activity on some standard or mechanisms. On the slide you see here, I try to present three of the main mechanisms used by the World Meteorological Organization. And sorry for the acronym. The one is the Global Data Processing and Forecasting System, or GDPFS. This is, if you like, the requirement needed for an operational center to be accepted by WMO, or all the center working under the WMO label need to fulfill the requirement of the Global Data Processing and Forecasting System. Another requirement, when it comes to the exchange of information, all the data, the exchange need to follow what is called the WIS, or the WMO information system. And of course, you heard before, when it comes to the observational network, we have what we call the WMO Integrated Global Observing System. So all these standards need to be playing for the activity to follow some standard. Can you move to the next one, please? Now, that's for the WMO standpoint, but when it comes to developing a climate services, a decade ago, many governments from the planet came together to try to lay ground for a framework to guide the development of climate services. This is something they call the Global Framework for Climate Services. But in this third framework, there is an important pillar, which is called the Climate Service Information System. In short, it is, think of it as the machinery, the engine, whether it is institutional or technical, which enable us to collect, disseminate, process, and even anticipate climate information about past, present, and future. Now, the strategy from the WMO was to say, for the implementation of this climate service information system, we need to think of a three-layer of activity. First, we need to have activity or center which are able to provide us with a planetary scale feature of the climate, because as you know, climate has no boundaries, so we need to have the global picture. So some center need to be established. Then we need to have a regional lens, so a center or institution able to provide a regional context to the information. And of course, we need to integrate the national level, because that's where the demand for services is stimulated. And of course, all the three levels need to interact, exchange, and for that, they need to have standards and rules. Can you move to the next one, please? Now, when it comes to the climate prediction or the forecasting system, we have this guideline. So basically, the member country have come up with a stringent rule of what can be accepted when we establish a center. So the guideline in red you see on your right-hand side is the Bible or the Quran or the Torah of all the requirements needed for operational center in the WMO realm. So can you move to the next one here? Now, in terms of the myriad of existing center, I just highlighted the typology of different centers. If you concentrate on the climate timescale, as you can see, operationally, WMO has three types of center. Center focusing on subseasonal forecast, one, on seasonal to annual, and there is a new kit in the block, which is the annual to decadal climate prediction. Can you move to the next one, please? So since 2017, WMO has established an infrastructure for the routine delivery of annual to decadal prediction. This platform consists of a lead center, which is a center hosted by the UK Met Office in Exeter, which is combined with the effort of 5 other centers, whose role is to provide every year an ensemble, a multimodal ensemble of annual to decadal prediction. And of course, there are other centers participating to the effort, which are not fully complying to the requirement, but they provide information. And one of the output of this effort is something called the Global Annual to Decadal Climate Update, which you heard in the previous talk, which is a kind of outlook of the next 2 to 5 years coming. And what kind of thing we can do with this, and if you move to the next slide, you will see the kind of question the policymaker can address. For example, with the annual to decadal climate update, we can respond on the question, for example, in the next 5 years, how many chances have we got to reach the 1.5 degree? What will be the regional area more affected by flood, drought, and so forth? So basically, every year in January, no, in February, this community will produce this what we call update, which is this outlook for the 2 to 5 years. And many other questions can be, but if you read the detail of the bulletin, you will see the variety of questions the bulletin is trying to respond to. But if you move to the next one, I just want to finish off with this slide here, whereby moving forward, what is the challenge we are facing? One of the challenges is to make sure the information produced by this platform is easily accessible. So one of the ideas is to try to lift the constraint regarding the data access, because so far the data are pass protected, but the community is thinking of way to alleviate this, especially for the research. There is also another requirement, because as I indicated earlier, for a center to be labeled WMO center, you need to fulfill the requirements for the global data processing and forecasting system. And in part of this manual, an important component weight is placed towards the verification. as you can imagine, when we talk about decadal, we don't have the same sample as when we talk about climate change, so maybe, or seasonal forecasting, so maybe some of the metrics need to be revised, so that's a discussion. And the key part is how we derive this global scale information at regional scale. Do we have mean to downscale? What happened in region where we don't have skill, and so forth. But those are open questions for the science, and we hope the science will help us address this. So I will pause here, and thank you very much for your attention.
Okay, thank you very much, both Kirsten and Wilfram, for giving us a couple of excellent presentations on relevant WCRP and WMO activities to the near term. So can I just ask the audience if there are any questions for either Kirsten or Wilfram? No questions? Not even from Madagascar?
Thank you very much. On the last intervention, when you mentioned opening accessible data, I think it's really important so that we can evaluate the performance of these products in our country, and that we can do feedback to even improve the product. Is it on the same way? Yeah, in such a model, for example, in such products of ECMWF, for example, instance, I think some products are made publicly available, like 3 or 4 years ago, but before it was only accessible for national methodological with password. So I really, we are happy that if at least for research purpose, some data will be accessible. That is really perfect. Thank you.
Okay, so if either of you would like to take that question.
Yeah, thank you. I fully agree with the question. Maybe one element here just to indicate. So the data produced by WMO is the free contribution of the member country. So there is a kind of bargaining where we need to negotiate with the center whether they are happy with opening the data. So I think we'll get there. That's my sense of it.
Okay, any further questions of the audience? If not, I will now hand over to Yugi, who's going to moderate the panel discussion. So if we could have all the speakers back up onto the...
Yes, so I'd like to invite all the speakers and also Ednan here. So we are running out of time right now, but since we have wonderful speakers and also fantastic audience here, so I'd like to have a short panel discussion and also hear from the audience very shortly. Then actually I'd like to start with our remote participation, remote speakers. So we see that there has been great advances in science development and science improvement for the seasonal to annual to decadal climate prediction, but Martin mentioned that there are huge gap between those science production and the use of in the decision makers. So my question to Wilfran and Christine is that what should be our priority to fill the gap in the next several years? And I feel that actually it is an important job for WMO and WCRP because IPCC cycle is too long to address those questions, and also IPCC we are assess existing science and literatures, right? So the current activities in WMO, WWIP, and WCRP are very crucial for the further development. So I'd like to invite first Wilfran for your thought for the priority for fill the gap, and then Christine.
Thank you very much, Junji. For me, I'm sorry, Kirsten, I thought lady will go first, but looks like I'm lucky today. So yes, but For me, the priority will again depend on the need of the member, on the need of the country, because the example of the La Nina event indicates that while we may be having good reason to focus on a multi-year fluctuation, in some part of the year, the subseasonal or the seasonal prediction will be a key issue. So basically, where we have the need, we will need to make sure the tool we have, the model, the science is helping us to address the question. So, and maybe that will also go back to the WCRP, because at some point we need to have an institution providing us the compass. What are the priorities from the science standpoint, because we need to translate the science into the operation. So basically, we will follow the science, but we'll try to be guided by the user need. That's my humble contribution here. Over.
I'll just add to that I fully agree that we're not where we need to be yet. There are user needs that are on shorter time scales, on smaller spatial scales than we have answers for in the climate science community. But part of the original impetus for these lighthouse activities was to try to address these broad questions from the World Climate Research perspective, rather than just from individual research groups or individual, national modeling centers. Having the coordinated efforts of the WCRP hopefully means we'll be able to make faster and more substantive progress. And Martin mentioned how our weather attribution capabilities are in a different place now than they were 10 years ago. And hopefully we'll continue to make those advances. We feel like our explaining and predicting Earth system change lighthouse activity is opening the door to shorter time scale, shorter than century time scale, but longer than weather. But in that intermediate range that we're starting to envision the ability for attribution capabilities. But I mean, there's a lot of work to be done. So it's not an easy job, and it will take us a while to get there. But having those user needs in mind, I think is a driving factor that will hopefully help us make progress as quickly as we can.
Okay, thank you, Efrain and Christine. Those are great answers. Then any further remark, maybe from Martin?
Thank you for those answers, and also for your excellent presentations. And indeed, I really see also how Working Group 1 and Working Group 2 in the IPCC have already come a lot closer. So we're thinking of the climate impact drivers that users are also interested in, and we're indeed guiding short-term research, but also long-term research strategies much more to those needs. And I see areas where also with the WMO community, for instance, we can build those bridges even more also toward practice. One good example, I think, is the Early Warning Systems for All initiative that was launched here. Well, actually it was already announced earlier by the UN Secretary General, but relaunched here. Also with a range of partners around the room, right, which includes the WMO, but also includes UNDRR, us as the IFRC, and a range of other partners actually thinking about what users actually need in terms of early warning, what it takes for them to act on it, but then also what you need in terms of observing systems, in terms of modeling capacities to generate those warnings. And that sort of end-to-end chain, I think, is what we need also for the longer-term climate science. And interestingly, if we do it well for early warnings, from the user side, we will have to generate the exposure and vulnerability information that is actually also what you need to program longer-term adaptation. And the sorts of questions that we'll be asking and the sort of gaps that we'll be filling in the short-term needs for early warning systems will also start putting the pieces together for, at least in the right way, asking the questions of how do we quantify these uncertainties? What sort of knowledge gaps do we need to fill in the coming 10 years, also working with the climate research community? So I hope that will be at least one place also where the collaboration is already very strong, and we can also find that connection to the longer-term climate science research agendas, which, like you said, Kirsten, I think we've already seen huge progress, and the collaboration between those communities is way stronger. I mean, I'm just thinking back of the AR5 and the different islands the Working Group 1 and Working Group 2 communities were sometimes working on, and then the very intense collaboration. I mean, I think I was contributing author to several chapters in Working Group 1, and we had several Working Group 1 authors in our chapter at least, but also across the Working Group 2 chapter. So I think that's been a real evolution that we can take forward in many areas, bringing the science closer to the practice, and vice versa, informing the science needs from the practice.
Those are great points, and yeah, I see that there has been more collaboration between Working Group 1 and Working Group 2 communities in AR6, but still I see that there are also gaps and limitations, and I found that actually Working Group 2 chapter 16 is the only chapter referring these climate impact drivers, right? So in that regard, I'd like to ask Jelena regarding how we can facilitate further for the collaboration or communication between Working Group 1 and Working Group 2 communities for preparing the next cycle of IPCC.
Right. Yeah, thank you, Jenny. I think one of the things is better understanding from even Working Group 2 authors of how this data can be used. Because I think in a lot of the work of Working Group 2 is looking at more the impact side, and we haven't really developed the causal links from the hazard. So we have floods, heavy rainfall, and so we're partly like restricted with the literature on researchers who are working to identify what are the impacts of hazards. So for example, in Working Group 1, you have multiple regions where you do a lot of the modeling. But in order to assess what are the impacts and adaptation, we are constrained by the literature. So there was the query, for example, from Madagascar saying maybe a country does have information, but it hasn't gone into the peer-reviewed press. So I think, as you had mentioned, we need to have that collaboration in areas where we probably have identified. So from the lighthouse activities, you can identify hazard is happening or in certain areas. And then how do we work with the people who are being impacted there to bring the results of the impacts up into some peer-reviewed or technical report, which could be taken by, Working Group 2 authors into that knowledge stream. I know I've also talked to some NGOs to say that they may have a lot of information working with communities and responding and building resilience, but they need to bring that information up into the peer-reviewed literature. But the other thing I think is probably for Working Group 2 authors, maybe there is because of the technical, the very strong on hard science, science from Working Group 1, there is maybe that trying to understand how to take that information and use it. So I think that's one of the things, but I think if we can try to build these causal links, heavy precipitation, flood, but flood why? Like Martin was saying, why is it happening? And then impacts, why are these effects happening? Because of vulnerability, because of societal issues, maybe ability to respond, space. So I haven't seen that causal link chain. It is starting to appear in the literature already, but a lot of it is coming from very specific case studies and people doing risk assessments. So I think we need a lot more of that. But I think it will happen within the next 5 years because of how it's starting to appear already in the literature, from the results from the Working Group 2 issues, the relation, the identification of complex and cascading risks. I know people are, once we see the economic impact, and we're seeing that already starting to happen within the last few years, there will be a much greater interest from industry, from private sector, from governments to try and put the link, and especially when you're looking at loss and damage, to try and put the link between the hazard and the impact and trying to put in the cost. So I expect that they should be within this next few years. So we hope that will bring that better connection between us. So I look forward, if I'm in that, I look forward to seeing that a better synergy between the two working groups.
Yeah, those are very important points. And Kirsten, I'm also involved in this lighthouse activity, and we have a Working Group 3 on climate hazards, as Kirsten introduced. Then actually, I think that the membership in Working Group 3 of this lighthouse activity are mainly in the Working Group 1 communities. So we may need to expand involvement for these climate hazard activities with this Working Group 2 colleagues. I think in that way we can have more synergies and more connection with the impact and risk assessment part.
I agree with you, Jeannie. I agree with you. I think that's an excellent idea.
Thank you. And Jelena also brought out the importance of compound risks. And I believe one of the scientific advances in Working Group 1 is to better understand and better project the risks of compound extremes. And we have this Muhammad Adnan from Chapter 11 of Working Group 1 on extremes. So would you share some of important assessment for compound extremes from Chapter 11?
Yeah, this is very important topic. According to the AR6 report, the probability of extreme compound events, including dry, hot, fire weathers, and compound flooding has increased in the past, and due to the human influenced climate change, and this trend continue to increase with further warming. This is so alarming. Further, the concurrent heat wave and the drought has become more frequent, and this trend also increased with high global warming. Further about the probability of compound flooding, including storm, extreme rainfall, and river flow, has increased due to the sea level rise and to the increase of the extreme precipitation, heavy precipitation events. Human influence is the main contributor to the increase in the frequency and intensity of extreme events. So there is a urgent need of adaptation measures to climate change is the only plausible solution to reduce the adverse impact of global warming on the environment, society, public health, and economy. Thanks.
Okay, thank you. That is a great point. And then maybe lastly, to Ajad, so I think the interactive atlas is great, but to build this interactive atlas, I think you have faced some challenges and gaps to better, provide those regional climate information to users. So what is your view to further improve those interactive atlas production maybe in the next cycle of IPCC?
Yeah, thank you so much. Actually, in the beginning, it was a huge challenge for us to even, and I think we reached a tremendous level from where we started. Regarding the gaps, I think, as you mentioned before, the IPCC has a bit longer cycle. So I think to meet the country demand, both from the north and the south, there's kind of need to develop a live early warning system for both at national and subnational level, maybe from the adaptation fund or maybe from the loss and damage side. So which may help early warning systems across the globe, both for the countries and in the north and south, particularly for the south where the capacities are low to early decision making, the warning kind of issues there, and to scientifically assess the coming threats to their region or their national level. Thank you.
Yeah, that is a very good point. And any further question or comment from audience? Yes? We cannot hear you well.
Hi.
Yes.
Yeah, Richard Betts from the Met Office, University of Exeter. So we've heard about observations, we've heard about early warning systems, we heard about attribution. The other area of climate science which has emerged in recent years is the ability to assess unprecedented events, so extreme events which are possible but have not happened yet. I wondered if the panel had any thoughts on the utility of that for this topic. Thank you.
Yeah, that is a great question. And actually, Martin, you actually touched upon those issues, especially some drought and Pakistan flooding events. So do you have any comment on that?
Thanks, Richard, and good to see you. We hadn't said hello yet, but one of those folks, along with Richard, and others, spanning these divides for many years. So thank you also for your contributions there. So yeah, I definitely believe this is a really important area of research, and it extends to what is unprecedented in a changing climate, but to some extent for disaster managers, it's already relevant to know what sort of things in the unchanged climate or the somewhat changed climate of now are possible but haven't been experienced recently. And to some extent, the regions, so there are two effects that can happen if you have a significant disaster event in a region. One option is that the region gets, and particularly in poor countries, that it gets so devastated that the region is left more vulnerable to the next disaster. People are poorer, protective infrastructure may have been damaged, hillsides may be barer. Certainly with I mean, you were mentioning the multiple extremes adding on top of one another, but for instance, first having a fire season which leads to deforestation, and then a flood season also makes it worse. So I mean, for all kinds of reasons you can be left more vulnerable. But from a behavioral perspective, what we often see is that people do prepare for the last disaster. So whatever they've just experienced, they're actually relatively well prepared for, but they're very unprepared for the things that they have not experienced recently. So even just knowing what the 1 in 50-year event is that you have not seen the last 50 years might be the most important thing to put on the radar of people, and especially if things are then changing and the unprecedented things are suddenly becoming possible. That is hugely important. We're starting to look at it on heat. Julie, who's sitting there, is actually working on that. Where we have already experienced a number of these cases where the human toll has been tremendous and we were absolutely not ready. And I think we need to work together between the science community and also those folks already dealing with those risks to put that much higher on the radar. So yes, high priority.
Yeah, that's great. And actually, I'd like to come back to you, Richard. So you are the CLA of Atlas chapter. So can you share your kind of view or opinion for the future direction for this improving the climate information?
Okay, thanks, Judy. Yeah, so I think there's a whole suite of things that we would really like to be able to do which we could build on in the Interactive Atlas. And in fact, there is actually some work that's happening within the European Union's Copernicus Climate Change Service in that direction. I think I would say the first thing is we need more observations in there. I think we're a little bit light on observations. I think that, I mean, in response to our friends in Madagascar, I think some more higher resolution information, or the ability to summarize information on finer spatial scales, I think that would also be something we would like to see. The regional assessments that are done in different regions of the world under the Codex protocol often do define smaller sub-regions and generate information over those regions, and I think that is very definitely a direction that we could also go with a future evolution of the Interactive Atlas. But I will leave that to the co-chairs of Working Group 1 of AR7 to see what they actually want to take forward on that front.
Okay, great. Oh, yes, Jelena?
Yeah, I mean, in the event just before us, they were talking about the hydrological database. So I think one of the other things, I mean, for flood and even drought event, would be to include river basins within the area. And that's what they were doing. They were talking about in the event before us. the Hydro SOS and the Global Water Project. So some integration or ability to share the data across, I think would be very useful for countries who want to try and assess, to build that assessment of a meteorological information with a hydrological information in order to probably predict potential drought or heavy rainfall events and flooding within river basin areas.
And just to add on to that, another thing that would be really nice that we try to do in AR6 would be to integrate Working Group 1 and Working Group 2 information into an interactive atlas.
Yes. Yes, great. So, yeah, we are almost running out of time, but I think this is a very useful discussion to fill the gap between Working Group 1 and Working Group 2 community, and also fill the gap between climate scientists and also user side. So for that, I'd like to hand over this microphone to Martin to close this event, because he is also one of the organizers of this event. Okay, Martin.
Thank you, and I mean, you've done the heavy lifting, so thank you is the main thing I want to use these final words for, to all the panelists, to those who stayed late after a long day, to those online who've joined us here. I think we've touched on an area where there's clearly a lot of work to do, but there's also already a lot of progress to report on. So I think we come out of this session with renewed enthusiasm, renewed commitment to take this further. I think there's a lot. I mean, I shared some of the appetite that has really grown in the user community for what we can offer. It's no longer an interface between the climate science community and an abstract long-term policy dialogue, but it's the climate science community, and in a way similar to what we've been experiencing in the weather community for a long time, the need to manage risks on a daily basis. And we've been talking about climate services for a long time, and I've been in that community to some extent. I've not experienced an appetite for those real climate services from the user side as strong as we're seeing it now. So I think there's a huge opportunity in the coming years, and we've seen many exciting examples. I think we have plotted a bit of the course for AR7, hopefully, but also for many other places where we just need to get on with this on the ground. It's also clear there's already so much there. We will learn in practice, and I look forward to that journey together with all of you. So once again, a big thank you, and to be continued.
Okay, thank you very much. Let's give a big round of applause to the participation and audience here. Thank you all. Thank you, Desvin. Thank you, Fran and Christine.
Happy to do it.